Hey everyone, ready to explore something totally new in social science research.
I'm excited.
Today we're doing a deep dive into generative agent-based modeling, or GBM.
GBM. Sounds complicated.
It is pretty cutting edge, but also super fascinating. It's like, imagine creating a virtual world where AI is acting like real people.
Okay, I'm intrigued.
Our guide for this deep dive is this paper about designing experiments using JBM with this platform called Concordia.
Concordia.
Yeah, it's developed by Google DeepMind.
Google DeepMind. Okay, getting serious. So, is this paper like a how-to guide?
Pretty much. It's all about making sure these JBM experiments are reliable and actually tell us something useful.
Reliable. That's important with any research, right?
Absolutely, especially when you're dealing with AI and complex systems.
Okay, I'm ready to dive in.
All right, let's start with the basics. What exactly is GBM? I keep picturing like a really advanced version of SimCity, with little AI agents running around.
That's actually a great analogy. GBM does involve creating these virtual worlds. But the thing is, the residents in these worlds are way more dynamic than in a typical video game.
More dynamic.
Yeah, so these AI agents, they're powered by large language models, think like ChatGPT, but for research.
Oh, wow. So they're not just following like pre-programmed rules.
Exactly. They can learn, adapt, they can even make decisions kind of like real people.
So it's like observing human behavior,
Yeah.
but in this controlled digital space.
Yeah, like a digital petri dish for studying how societies work.
I like that. Okay, let's say I want to study how rumors spread, like in an office setting
Perfect example. With GBM, you could create a simulated office, like you said.
with AI employees.
Each agent would have their own personality, their relationships with their colleagues, even memories of past interactions.
Oh, you can get that specific.
And then as they interact, you can track how information and misinformation flows through that network.
That's incredible. But okay, this all sounds really cool, but why should someone who isn't a scientist care about this?
Great question. This isn't just a tech demo, this stuff has real world applications.
Like what?
Okay, imagine you're trying to understand how people might react during a disease outbreak.
Oh, like during a pandemic.
Exactly. Researchers have actually used JBM to simulate that. They created a virtual town where AI agents could choose to self quarantine.
Based on what they knew about the virus.
You got it. They could then see how individual choices impact the spread of the disease, like on a community level.
That's amazing. So it's almost like a social science time machine?
Exactly. You can run all these different scenarios and see how things might unfold.
Right. We've got these AI agents in our simulation, but where does this Concordia platform come in?
Concordia is like the toolkit for actually building these experiments.
Mhm.
It's designed for JBM from the ground up.
So it's like user friendly for researchers.
Relatively, yes.
Yeah.
Much easier than starting from scratch. And this paper lays out a step-by-step guide.
Oh, cool. Like a JBM recipe book.
Exactly. They break it down into 4 steps: conceptualization, tool selection, design, and then execution.
Okay, I'm ready to cook. What's the first step? Conceptualization. What even is that?
It starts with your research question. What are you actually trying to learn about?
So before you build anything, you got to know what you're looking for.
Right, so the paper uses this really cool example. They simulated information spreading on a fictional social media platform.
A fake social media.
They called it ConnectNet. And they created these 5 different AI personalities for their world.
5 personalities.
Alice and Bob were influencers. Then there was Dana and Evan, regular users. And then, get this, Charlie, who was actively spreading misinformation.
Oh, wow. So they built in a fake news spreader?
They wanted to see how misinformation interacts with real information in a social network.
That's smart. So you can track how it spreads and maybe even how to counter it.
Exactly. By observing how these AI agents interact on ConnectNet, researchers could get real insights into the dynamics of online information.
Okay, that's super interesting. So we've got our research question, our virtual world, even our personalities. What's next?
Next is tool selection. Time to pick the brains of the operation.
The brain.
This is where you choose the specific large language model for your AI.
Oh, so it's like picking the engine that's going to drive their intelligence.
Yep. Different models have different strengths, kind of like choosing between a gas guzzler and an electric car.
Makes sense. What did they use in the ConnectNet example?
They used a model called Mistral, but the cool thing about Concordia is it's super flexible. Researchers can use a variety of models.
So lots of options.
Tons. All right, once you've got your model, it's time for the design phase.
Design. This is where it gets creative, right?
It is. This is where you flesh out all the details of your world, the environment, the rules, the agents themselves.
So not just personalities, you're giving them backstories, relationships, everything.
Exactly. You're crafting their memories even. It's wild.
This is taking those simple simulation games to a whole other level.
I know, right? And the paper actually shared a bit about how they crafted the memories for one of the ConnectNet agents.
Right.
Super detailed. It felt like reading a character bio for a movie.
Wow, okay, I'm hooked. So world designed, characters created, then what?
Now it's showtime, the execution phase.
Hit the play button.
You got it. Your agents start interacting, they're learning, they're adapting, and you get to observe the whole system evolve.
So you're watching this AI society unfold.
And the paper actually includes snippets of what those ConnectNet interactions look like.
Oh, cool.
You can see the agents reacting to posts, spreading information, even trying to counter the fake news Charlie was putting out.
Like a mini society playing out.
You do.
Okay, I have to ask though, how do we know these simulations are actually telling us something useful about the real world? It's all happening in a virtual space.
$1 million question. And it's something the authors of this paper definitely address.
So how do we make sure it's reflecting something real?
One way is to use data from past experiments as a benchmark. If you have real-world data, you can compare it to your JBM results.
So like checking your virtual lab results against what actually happened.
Exactly. But sometimes you're exploring something totally new, no real-world data exists.
Oh, right, that makes sense.
Mm.
What do you do then?
Things get a bit trickier. Researchers have to rely on logic, common sense, make sure the results are plausible.
So even though JBM is using AI, it still needs human judgment.
Always. It's a powerful tool, but not a magic bullet.
It's more about asking better questions, right?
Exactly. Exploring complex scenarios and ultimately gaining a deeper understanding of how the world works.
That's a fantastic way to put it. We've covered a lot of ground in this first part of our JBM deep dive,
We have.
but there's still so much more to explore. We'll be back in the next part to delve even deeper into this fascinating world.
You know, it's amazing with JBM.
What is?
It's like we're peeking behind the curtain of like how societies function.
Yeah.
But instead of a stage, we've got these algorithms.
And simulations.
Exactly. And the cool thing is we can like rewind, fast forward, even change the script, see what happens.
Speaking of changing the script, I was wondering about this game master the paper mentioned. I didn't quite get what it does. Oh yeah, the game master. Sounds like something out of a video game.
Well, in a way, it kind of is. It's like the one in charge of the whole JBM simulation.
Keeping everything running.
Yeah, managing the flow, making sure the environment responds realistically to whatever the AI agents are doing.
And keeping track of all the data.
Exactly. It's constantly checking the agent's actions, updating the environment, giving feedback to the agents, lots of multitasking.
Sounds like a pretty important job.
Yeah,
So if the game master isn't designed well?
the whole simulation could be messed up.
Oh, wow.
The game master has to be complex enough to handle everything, but also transparent so researchers can understand what's happening.
So it's like a balancing act.
For sure. And it all comes back to that reliability thing we talked about. The game master is really important for making sure the simulations are, like, believable.
So it's not just a cool virtual world, it's got to make sense.
Exactly. A world with its own logic. That's what gives us confidence that the insights we get from these simulations are, actually applicable to the real world.
Makes sense. It makes me think about those snippets from the ConnectNet simulation in the paper.
I know, right? So cool. It was like reading a real conversation from social media.
It really was. And they also showed how each agent's memory was structured, how it changed over time.
That's what I love about JBM. The agents aren't just reacting randomly. They're using their past experiences, forming beliefs, making decisions based on all that.
Like each AI has its own little story.
Yeah. And that detail is what helps us understand human behavior better. Like how people react to information, how social networks can shape beliefs, how little things can have big consequences.
Okay, so we've talked about public health, information spread, but where else could JBM be helpful? It seems like it could apply to lots of things.
Oh, absolutely. Imagine using it to model like traffic patterns in a city
Oh, that's a good one.
or how an invasive species might spread.
You can even look at how economic policies impact people differently.
Exactly. The possibilities are huge. But we do need to be realistic. No simulation is perfect, right?
Yeah, the real world is messy.
JBM is powerful, but it has its limitations. Remember, it's all based on models and algorithms which simplify things.
There's always going to be a gap between the simulation and reality.
For sure. And that's why transparency is so important. Got to be upfront about the assumptions you're making and don't overinterpret the results.
Like they say, all models are wrong.
But some are useful.
JBM can be super useful, but got to be mindful of its limits.
Can't treat it like it's the absolute truth.
It's more about finding insights, generating hypotheses.
Not replacing real world research, but adding to it.
This has been so interesting. We've talked about so much already, from the basics of JBM to this game master and how reliable these simulations are.
And we're not done yet.
There's one big question left. What's the future of JBM? Where do we go from here? That's what we'll be exploring in the final part of our deep dive. All right, so we've spent the last two parts really digging into JBM. I gotta say, it's exciting stuff. Simulating these complex social interactions to learn about human behavior, it's incredible. But what's next? Where does JBM go from here?
Well, the paper hints at some really interesting possibilities. Like, they talk about developing even more advanced AI agents.
Even more advanced.
Yeah. Imagine agents that can not only learn and adapt, but also, like, understand emotions.
Whoa, emotions. AI with feelings.
Think about it. Agents that can respond to each other's emotions, build trust, maybe even experience conflict, but in a more nuanced way.
So the simulations become even more realistic, like a true reflection of human interaction.
Exactly. And that gives researchers even richer data to analyze.
I'm starting to see how this could revolutionize how we study human behavior. It's like having a microscope for society.
That's a great way to put it. And as the agents get more complex, the simulations can too.
Yep.
We could be modeling entire cities, economies, maybe even global systems.
Simulating an entire city, that's wild. Like a virtual crystal ball for urban planners.
Right. And think about other fields too: public health, education, even urban design.
Okay, all this sounds amazing, but is there a risk? I mean, what if these super intelligent simulations get, well, too smart? Start making decisions we don't like?
That's a really important question, and it's something researchers are very aware of. As we build these powerful AI systems, it has to be done responsibly, ethically.
So it's not just about advancing the technology, it's about using it for good.
Absolutely. And that's why collaboration is so important. Computer scientists, social scientists, ethicists, policymakers, everyone needs to work together.
So we're all on the same page, making sure JBM benefits humanity.
Exactly. It's like we're on this journey of discovery, and we need to make sure we're navigating it carefully, thoughtfully.
I love that analogy. And I think this paper gives us a good starting point. They really emphasize transparency, good experimental design, thinking critically about how we use JBM.
Couldn't agree more. And you know what else they talked about? Creating a platform where anyone could build and run their own JBM simulations online.
Wait, really? Anyone?
Imagine that. Students, policymakers, even just regular people could test out different scenarios, explore these complex systems.
Democratizing access to these powerful tools. I love it.
Me too. It really shows how transformative JBM could be. It's not just for researchers, it's a way to empower everyone.
Well said. Well, I think it's time to wrap up this deep dive into the world of JBM. It's been a fascinating journey.
It really has.
And for everyone listening, we hope this deep dive sparked your curiosity about this incredible new field. Maybe it even got you thinking about the questions you would explore if you had the power of JBM at your fingertips.
Yeah.
The possibilities, they really are endless.